Welcome back to Demystifying Computers, where we unravel the mysteries of technology. I'm Christopher, and in today's episode, we're diving into the fascinating world of programming languages, the tools that enable us to communicate with computers and instruct them to perform tasks. Programming languages serve as a bridge between human-readable instructions and machine-executable code. They allow programmers to write code using syntax and semantics that are easier to understand and manipulate than the raw binary instructions understood by computers. Let's start with one of the earliest programming languages, assembly language. Assembly language provides a symbolic representation of machine code instructions, making it easier for programmers to write code compared to directly manipulating binary instructions. Despite its simplicity, assembly language is low-level and closely tied to the architecture of the underlying hardware. This makes it less portable and harder to maintain for larger projects, leading to the development of higher-level programming languages. One such language is Fortran, developed in the late 1950s for scientific and engineering computations. Fortran introduced features like loops and subroutines, making it easier to write complex mathematical algorithms. Following Fortran, other high-level languages like COBOL, Lisp, and ALGOL emerged, each with its own strengths and applications. These languages introduced concepts such as structured programming, recursion, and dynamic memory allocation, paving the way for modern software development practices. In the 1970s and 1980s, languages like C and Pascal gained popularity for their simplicity, efficiency, and portability. C, in particular, played a significant role in the development of operating systems and system software, thanks to its low-level features and close relationship with the underlying hardware. As computers became more powerful and versatile, the demand for higher-level languages that could handle complex tasks increased. This led to the rise of languages like C++, Java, and Python, which offered features like object-oriented programming, memory management, and platform independence. Today, programming languages continue to evolve to meet the growing demands of modern computing. Languages like JavaScript, Ruby, and Swift have gained popularity for web development, mobile app development, and other specialized applications. In recent years, we've seen the emergence of new paradigms and technologies like functional programming, concurrent programming, and artificial intelligence. Languages like Haskell, Erlang, and Julia are pushing the boundaries of what's possible in terms of expressiveness, performance, and scalability. As we look to the future, the role of programming languages in shaping the digital landscape will only continue to grow. Whether it's powering the next generation of intelligent systems or revolutionizing how we interact with computers, programming languages will remain at the forefront of innovation and discovery. And that's a wrap for today's episode of Demystifying Computers. I hope you enjoyed our exploration of the evolution of programming languages. Join us next time as we delve into another captivating topic in the ever-changing world of technology. Until then, keep coding and stay curious.